class. This lecture is about dealing with time in Excel. Time is a very important variable and it's present in a lot of data that an engineer processes using Excel. Um, Most of the engineering measurements are you're looking at some variable or the other changing with respect to time. So a lot of sensors, data acquisition systems, and data coming from several other locations usually have a time column. And once this data is brought into Excel, we are looking to do several types of simple and complex time-related operations. And there are plenty of options within Excel to perform such operations, and there are several functions that are available in Excel, which makes our life easier. So a lot of things that we'll do in Excel related to processing time would be dealing with different types of time formats, um, which varies by region, and within a region which varies by preferences or of different organizations, etc. We'll also deal with simple time arithmetic, including addition, subtraction, uh, also finding an elapsed time between two events, finding an average over time. For example, some variable is changing, so you wanted a time-weighted average. It could be variables like velocity. What is an average velocity over time? What is an average velocity, an average force, an average momentum over time, an average temperature, things like that. We also would like to sometimes know what is the time of occurrence of an event. So when happens, and we are collecting data and it's captured in that data, we would like to know when exactly that event happened and whether subsequent events that are related to that event did happen or not. So finding the time of occurrence of a certain event within the data set. Then a lot of times what happens is we have different measurement systems. They may be trying to monitor the same process. So when they're brought in together as a combined data set, we'll have to synchronize time between these two data sets, which means we want to make sure the start time and stop times are synchronized. So we'll deal with some of these basic things that an engineer has to deal with on a day-to-day basis in relation to processing time within Excel. So before we delve into most of the details on how to process time, let's look into some of the very basics of how is time handled within Excel. If you learn these concepts, a lot of things that might look confusing later on due to change in time formats and all that would be that the mystery will be demystified for you. So what you need to understand from the very beginning is Excel can store time as either a date, which is, January 1st, 2024, for example, or a time, which is 9 a.m., 10 a.m., um, or 24-hour format, which will be 14, 17 hours, things like that. You could also store a date plus time format. For example, it could be 12th September 2024, 5 p.m. So it can store in three different ways. The dates are stored as numbers, and that to whole numbers. So there's no zero. Dates are stored from 1 to the largest number that Excel can store, depending on whether the world makes it to that many years. Um, so then the first question you will ask is, what is date number 1? What is the date that corresponds to number 1? Well, the date that corresponds to the number 1 stored is January 1st, 1900. So that's the first date available in Excel. So anything before that, it's hard to handle in Excel. We usually don't need to worry about that. Um, and how are the time that handled? Times are stored as fractions, decimal fractions of a 24-hour day. So if you're talking about 12 a.m., that's when the day starts at midnight, then that number is 0. And then let's say 30 minutes past that, 12 hours and 30 minutes. So that will be 30 minutes divided by 60.5 divided by 24. Okay, so that's the fraction of the 24 hour. 6 a.m. would be basically 6 hours past that. So 6 divided by 24, which is 0.25. And 12 p.m. would be 12 hours past that, which will be 12 divided by 24, it's 0.5. Okay, so that's how you do the time. So these are basically the number values which are similar to the corresponding time format. And the dates, as I mentioned here before, January 1st, 1900 is number 1. And let's say 9/21/2024 corresponds to a huge number. So this many days have passed since this date. So that's what this number represents. So naturally, when date plus time happens, it is going to be a sum of this and a fraction on the side. So you'll get something like this. So it could be a fraction or a whole number, depending on whether you're adding a 12 p.m. Sorry, a 0 or a 1 here, which is 12 a.m. or one day after that at the same time, which is 1 24-hour period. So in those scenarios, you'll get a number value too, a whole number value. Let's look at that in Excel here. So here, and by the way, this Excel file will be shared with you and you can play with it. Um, Here, this value function is looking at the number value of different time formats. So if we change here, for example, the 2:45 p.m. we change to 2:55, you can see it gives another fraction. The only two times we get an integer is at 12 a.m. and 24. Okay. Now, today is 9/20/20 or 22nd September. So that is 45,557 days since January 1st, 1900. So that's why this number. Okay. Now, what if I tried to put a date before this date? So if I go to 1800, I get no value here. So that means there's dates before this is not possible in Excel. Okay. So if I change this to 1900, you're 245 days past this January 1st. Okay. And date plus time, as I've mentioned before, you most of the time you get a fraction. And you change this, um, for example, the 6 a.m. to 6:45 a.m. That changes this to a different fractional number. So that's the basic of time stored in Excel. A lot of times when you have formats like this and you change the date format to a number, it will show you the number value. And it gets confusing a lot of times when the number is so large. But now you know where that number is coming from. It is coming from how many days have been elapsed, how many hours have been elapsed since this particular day. Okay. All right. Next thing we'll deal with is date and time formats. Excel provides several predefined formats to display dates and times, such as these. So in this case, you can see there are several date formats, and these are all from United States. Um, these are different time formats, you know. So in some of these cases you can display a PM, some of these cases you can display the seconds, some just up to minutes. Again, this is also English United States format. Um, if you go to Excel, and go to Numbers tab, go to Date. You could choose the country here, okay? And for example, if you try to look for Thailand, you can see what are the options available there. Thai. So you have some typical date formats that are possible in Thai. So all you're doing is basically how the text is displayed, but the value, the number value is going to be the same. It'll be how many days and hours have elapsed since January 1st, 1900. Okay. So this is how it's just displayed in that cell. So you can choose to display it in Thai numerals or English format or British format, any of those. Same thing with time. Okay. Here I have given you some of the common formats that are in that are mostly used. So if you have a time, for example, and that's it, US format, 9/10/2024, okay, and you want to change it to Thai format, all you have to do is um, select the Thai format, format painter, click on the English format, and you'll have it in that format. Now you could also do the same thing. Let me Control Z here. You could also do the same thing by going to the number tab, um, going to the date format and choosing the the Thai date format, if I could find it. Yes, do it this way. Okay. But once you have saved this formatting anywhere as an Excel file, it'll come in handy whenever you want to change something. So if you have if you can create your own with whatever you would like this, it could come in handy later on. So you can create that a bunch of these formattings at in an Excel file using um, uh, this pre-filled formats that are available, and then just copy the format. In addition to that, within the same section, so we looked at basically the predefined formats for dates and time and the date plus time combination. Excel also allows you to create custom date and time formats using specific codes, okay? And these are some of those codes. So um, I can go deeper into that if you have questions in the classroom. But all you need to know is if you are not, for some reason, not liking any of these formats, you can create your own date format, okay? And what you do is go to the Numbers tab, go to Custom, and create your own. So you um, can select this, for example. I'm sorry. Select this, for example. You could custom type in a format here. Uh, you could say, I also want AM, PM, for example, or I also want the day displayed as 2 letters, for example. So things like that. You can have your own custom format, and you could either read up online or in some Excel tutorials, you have a little bit of format codes I've given here, So if you want to display the full month name like January, you have to put 4 M's. If you put 3 M's, you'll get a 3-letter month name, things like that. Okay. The 4 D's would give you the full name of the day. 3 D's would give you just the 3 letters of the day, and 2 D's will give you the 2 numbers that corresponds to that day. Okay, things like that. So that's about the date formats in Excel, date and time formats. The next is date and time functions. Okay, there are several date and time functions in Excel, and you would access I didn't cover this in the functions lecture before because I thought it should be with the with the time series lecture. Um, but it's in the same location where the functions are found under the formulas tab. So if you come here, you'll see date and time, and you'll see, I think, roughly 25 functions in here. And what they do are explained in the same Excel file here, and you can see I've given a description, and the formula I've used here had been shown using the formula text function, and this is an example of a calculation. So, so the date gives you returns the actual value of that specific date, which could be also done by a value function. I've highlighted some of the ones that you might find useful, um, but as you will see in the upcoming sections, you could do a lot of these things without these functions because once you understand that the basics, that it's all based on this date and things are moving around based on that, there are a lot of operators that you can use to uh, the simple addition and division, plus, minus, things like that are much easier to use than some of these functions. Okay. Um, the next section would be, we'll be talking about some of the date and time arithmetic, which is basically adding some number of days or number of hours or number of minutes or number of seconds to a particular date or a time or a combination of date plus time. Okay. So, um, so in this particular case, we are dealing with addition. It also applies to subtraction. Okay. So the plus, you just could take it to minus. Let's go to the Excel file and look at it directly. Okay. So let's say you have a starting date. Okay. Um, by the way, here I am using a today function. So today is 22/9/2024. Today function gives you today's date. And now function will give you both the date and time. Let's try that. So, so I'm preparing this lecture at 8:26 on 9/22/2024. So it gives you the actual time. Okay. So you have a starting date and you want to count 4 days from that date. What is the date? 4 days from that date. All you have to do is just add 4 to that. Okay, because number of days is just in time format, it is basically, or in the Excel storage format, it's basically counted as 1. So each day is counted as 1. So you just add 4 to this and you got the final date. But sometimes this will be displayed. For example, let's try to write that here. Oh, because, okay, sometimes it could be displayed as a number, like this. Don't get confused. All you have to do is just format Painter and place that. You get the same answer. Okay. So then in this case, it's starting date plus time. So in here there's a time also involved, and you add 4 to that same way. It gives you a date and time, adding 4 days to it. Now, if you want to add hours, what you do is there are two methods. One is, okay, hours is a fraction of 24. So if it's 11 hours, what you have to add is 11 divided by 24. Okay, so you'll just add this value to 11 divided by 24. Okay, if it was 24 hours, that means it's 1 day. So you'll be adding 24 divided by 24, which will be 1. So you'll be adding 1 day. Okay, so that's how you would add hours. If you have to add minutes, what you will do is convert that minutes to hours and then divide by 24. So you convert the minutes to hours by dividing by 60 and then divide by 24. So you have a 24 and a 60 in the denominator. Okay, as simple as that. Um, Seconds will have one more 60. Okay, because 60 minutes, 60 seconds is 1 minute. So you'll add one more 60 in seconds. But do you see I have put in another method in here? Instead of dividing by 24, I have put in this um, 100 in quotes and multiplied that with 11. That's another method which very few people know. And majority of the time I use this method because this is what I'm used to doing. What this tells you is I know 11 is hours, so multiply 11 with the hour, which is 1 here. Minute is 0, seconds is 0. Don't multiply any minutes, don't multiply any seconds. Okay, 1 colon 0 colon 0 is basically minute, um, hours, minutes, and seconds. So 11 has to be multiplied with hours. Okay, then it takes care of converting that to the right number here. Okay, so it knows that I'm adding 11 hours to this time. So it will take care of the dividing by 24 by itself. Okay, in this case, I'm adding 120 minutes. So 120 is minutes. So hours is 0, minutes is 1, seconds is 0. So it knows accurately how to do that. And you can see I get the same answer here and here as dividing by 24 or dividing by 24 and 60. And sorry, this should be number of seconds here. Um, so number of seconds, you'll have another 60 in here. And in the same way, I will be doing a 1 at the very end. And you get the same answer here. Okay. So that's basically addition. Okay. Next one is finding an elapsed time between two dates or two dates in dates plus time or two times. So if you have two different dates, how many days are between those two dates? You can use the days formula, okay, which is one of the functions is in here, returns the number of days between two dates. Okay, but it only returns a whole number. It doesn't give you the hours. If you have fractional hours in between or fractional days in between, it doesn't do that. So days function um, returns the number of days between two dates. So that's this, 4 days. Another option is just subtracting the 2 days. That gives the number 2. Okay. What if it's 2 days, they're not 2 different days that are not multiples of 24 hours? Okay, it's at 1:36 p.m. and here it's 4:36 p.m. 2 different dates. This days function still gives you 4 days. Okay, it doesn't give you that fractional hours that are different from here to here. So just simple mathematical operation seems to be better than the days function to give you a more accurate number. Okay. Um, Number of hours between dates. So here you get the number of days. Number of hours will be basically nothing but just the difference times 24. Okay. Another option based on what I had shown before is you divide it with 100. So 1 represents hours. Okay. So, and also you get the same number. So divide with 100 within two quotes. Same thing goes for minutes. So in this case, 24 times 60, because 24 is for hours, and converting that to minutes, you have to multiply by 60. And the other case, in the method 2, you will divide by quotes 0, 1, 0. Similarly for seconds. So that's about date and time operations. Now we get into a little bit more detail. Plotting time data. Okay. Now you have, let's say you have database, you have generated database between different sensor measurements, and each one have its own time and then the actual measured value. Um, Sometimes we have seen this kind of data. In your case, you have seen it in our previous example where I had given you a CSV file which had time on one column and a humidity and temperature on the other two columns. Okay, a similar data here. Um, when you get that kind of data, when you have to plot, to make any sense on the x-axis, you want to convert that to hours or minutes or something like that instead of an actual date and time, which will be hard to tell how many hours passed or how many minutes passed in this axis. So you need to convert that into hours or minutes or seconds for plotting it. Okay, and you don't have to worry too much about the details of charts and plots. We will have another lecture on that, but I'm going to jump over that portion uh, uh, really quickly here and then come back to it in the next lecture. Um, so if you look at plotting time, let's say this is the data you got from column A to C. Okay, to generate a plot like this, where you have hours on one axis and your measured value, humidity, on the other axis, um, the first thing you need to know is what is my zero time. Okay, so a lot of times people choose the first data point as their zero time. Okay, let's say that's your start time. In this case, date and time are in two different columns. So I'm picking this first row as your start date and start time. So I write it again here. You don't have to do that. You could just use the same row here, but just for clarity, I wrote it again here. Okay, so this is the start date and start time for our data. Now I create a column called hours, method one, and the first value here is, with respect to this, I subtract the start date. Okay, start date is subtracted from the first date number here and multiply that by 24. Okay, I'm trying to convert everything to hours. Okay, so if it's in days, we are trying to convert that into hours. Same thing goes for the time. Okay, whatever this difference is, multiplying that into hours, multiplying that with 24. Okay, and you also notice the dollar sign here because I'm gonna basically double click and generate the whole columns, and I don't want these references to change. This is the start date and start time with respect to every single time. So as the time goes by, this difference between this and the next time keeps on increasing, and that's how we generate this hours for method one. And the formula used is shown here is the formula text, using the formula text command. Could do the same thing using the 100 method I had shown you before. 1 represents hours. Okay. Now the same data could be generated for minutes instead of hours. In one case by multiplying by 60. Okay. In the other case by using 010 instead of 100. Okay. And that's how we generated these time in hours or minutes. You can pick your preference whether you want to just use the 24 and times 60 method or use the my favorite method, which is 010. It's up to you. So that's all about plotting time, getting data in a date and time format. And a lot of times it won't be like this. You might have a date and time format where the date and time are combined like this. Okay, like this. Now it's separate columns, but it's the same deal. So you would choose your start date and time as a single column also, and then keep subtracting it, and the formulas will become simpler. Same deal. So that's about plotting time and data. Now the most important portion, which is synchronizing time and data, time data. This is needed when you have multiple data sets, like I mentioned before, from different sensors or measurement devices, and they're supposed to be compared because they are measuring the same process or event. So they need to be plotted, let's say, in a single chart. So time data from one of them might be at a different frequency compared to the other time data. For example, one may be logging at every 1 minute, the other might be logging at every 30 seconds. Okay. And a lot of times it happens that two different computers or measurement systems, there could be an offset in time also. So 1 p.m. in one data set may not be the 1 p.m. in the other data set. In reality, the 1 p.m. in the one data set may be 1 p.m. and 20 minutes past. So there will be some offsets between the data sets too. And this is a big problem, especially in US, because there's something called daylight savings feature, and some computers enable them, some computers don't enable them. And because of that, there is sometimes 1 hour, 2 hours um, offset. And a lot of times engineers could get into some uh, wrong data analysis if you don't synchronize your data. So how do you do that? So in this particular case, assume that you have a sensor 1 data and a sensor 2 data, and sensor 1 data is logging every 1 minute, sensor 2 data is logging every 4 minutes, but they're both logging the same event. In this case, they're both measuring the humidity and the temperature inside a refrigerator. Okay. Um, so this is the original data set you have. At least for one that you think the time data is correct or is the more correct one, you choose a starting time for that one. Let's say, you know, this is the starting time. You'll choose that starting time here and creates this hours or minutes chart for it. So use that, and just like last time I said, in plotting time, use the same method to create its hours chart. For the second data set, create another hours chart, but try to add an offset value to it. So you're basically using the same time to create an hours chart, but you also have an added number, which is an offset. That offset is basically trying to figure out how much is the actual time difference between the two data sets. Okay. Um, one other thing to note here is if you look at the count of how much data points is there in one of these columns, it's 404 because it's logging every 4 minutes. In this case, it is 1570, so almost 1600. So almost 4 times data is there in this column versus this. So if you don't plot against the right time value, you might end up getting nonsensical data. So let's see what has happened here. This is the data for temperature, and its temperature, um, it's plotted against the hours of temperature. This is the data here for humidity, and it's plotted against the hours of humidity. Okay, so in this case, there are almost 1600 data points, and in this case, there are, okay, in this case, actually, there's only 400 data points. I ended up selecting more, um, but that doesn't matter. So let's see what happens if there's no offset. Okay, you can see that the peaks and the troughs don't match. So there is an intentional offset that I created in the data for educational purposes here. For it to match, I actually have to move my temperature data a little bit behind, which is the orange data. So I'm gonna subtract it by minus zero point 0.5. Now we have more synchronized data points. The peak and the peak matches, and the trough matches. Okay. So this is how you synchronize data. So you can see if I put any other number, it moves around with respect to this. But you'll need to know exactly based on some other event or additional information how much that offset will be. In this case, because I put in the offset, so I basically know it is zero point 0.5, which is nothing but an offset of how many minutes? 0.5 is the hours, so 0.5 times 60, that is 30 minutes. So there's a 30 minutes offset in this data, which can be fixed by subtracting a minus zero point 0.5. So that's about synchronizing data. Um, so this lecture concludes here. We'll discuss a lot more in class, depending on how many questions you have on this topic. Thank you.